Okay, so welcome back. This is part 5 in our series. We're going to help you to understand ray tracing, and specifically in this video we're going to start to look into the GPU and how that works, and some of the tools we need to start writing our own software to access the GPU. And we're going to be working with CUDA, and we're going to start thinking about how does CUDA work and how can we implement it in our GPU so we can do stuff like this. And here you can see we talked about in previous videos about rendering in Blender, and Blender is going to be a really good tool we can use to see what happens and see how to implement it. We can also look at the code directly, the Blender code. It's open source. We can look at the code and see how it works. Here we've got our Blender scene, and what we can do is we can look at Task Manager, and we're going to talk about that in this video, where we can turn on a render. We can actually render our scene, and you can see here Task Manager shows us that the CUDA engine that's doing the work on the GPU is actually up at 80 or 90% utilization. And you can see we've increased the memory. So we're going to talk about in this video how we can use some of the tools to give us good feedback on what's going on with our GPU. So we're going to build a simple application, Visual Studio, using C++ and CUDA, to do some simple math on your GPU. And we're going to get some feedback, and it's really important, especially when you work with GPUs. It can be kind of a challenge to make sure you really understand what's going on with your GPU. So we're going to use some tools to get some good feedback on what's going on in the process, so we really understand a lot better what's CUDA doing, what's the GPU's doing, and so on. So we're going to be doing some timing, but we're also going to be using this tool right here called Task Manager from Windows. And you may not be aware, but it can give you some really good information on what's going on. So I wanted to get us familiar with Task Manager and its capabilities before we jump in and start writing the code. Because we're going to use this to get a visual depiction using some of these graphs in Task Manager of what's going on, and making sure we understand what's happening on our computer and on the GPU, so that we don't have to rely on sometimes confusing information otherwise. Basically, if you start up Task Manager, go to the taskbar, right click and select Task Manager, it'll start up, and if you go to the Performance tab, you'll probably see on the left CPU, and here it lists the activity in my CPU, all these graphs on the different cores. I've got an 8-core processor. I've got system memory, and you can see here memory. I've got 64 gigabytes of RAM, and down here it's got some interesting information on some of the data associated with my RAM. Then I've got my disks, I've got Ethernet, and down the bottom here you can see I've got 2 GPUs. I've got GPU 0, and if I select that, you can see up top right, GeForce GTX 1080 Ti, and the other one is GPU 1, which is a GeForce RTX 2070 Super. So I've got 2 GPUs on my PCI bus. So what we're going to do in our application is we're going to gather some data from these and select which one we want to do the processing with. And this Task Manager is going to be very useful to see, hey, I think I'm doing this on this GPU. Is it actually happening? And this will give us some good feedback. Back in the main memory, you can see we've got memory, 64 gigabytes. And down here, it tells us how much is being used. And right now, I have in use just about 10 gigabytes out of the 64. And that's because I'm doing my recording of this video and so on. And it says I've got about 54 gigs left. So here I've got a graph of memory usage, and this is the last 60 seconds of memory usage. And we're going to use that because in our application, we're going to grab a whole lot of memory, so we get a very clear indication of memory usage in this graph. Our application is going to grab like 8 gigabytes of memory, just so we get a really good feedback from this graph about what's happening in our main memory. And then if you go down to the GPU, it has these 4 graphs up here, and then this other graph says dedicated GPU memory usage, which is very similar. And in this GeForce GTX 1080 Ti, you can see on the right, I've got 11 gigs available, and it shows me what's being used. And it's got a graph for the last 60 seconds or whatever. And if you look down here, it says dedicated GPU memory, and it says I'm using 0.7 gigs out of 11 gigabytes, all right? And over here, it's got some driver version, driver date. It's got physical location on the PCI bus, which device, which function. So good information here. And it's also got a GPU temperature. The same thing with this GPU 1. Basically, it's not doing anything right now because this GPU 0 is the default and it's doing all my recording and everything else. So up top, we've got these 4 graphs, and you can see when you start it up, it defaults to this one is 3D, this one is copy, video encode, video decode. So what is this about? These are what are called engines, and an engine is on your GPU, and it's basically a specific configuration of hardware that is designed to perform certain tasks really well. So for example, there's one engine that does 3D. There's one engine that does copying. There's one engine that does video encoding and one that does video decoding. So the video encode engine is configured to do video encoding really, really well. Whatever the processes are needed to do video encoding, this engine is designed to do that really well. So you've got these utilization of these different engines, and I can go up here. Notice there's a drop down. This is really important. People don't know about this, but if you drop down, you can see all of the engines that are available, virtual reality, compute, and you can see here I've got a CUDA engine. So I can select that, and presumably it will show us, if we're working with CUDA, what is the CUDA engine activity. Now, one of the challenges here is you're never quite sure what engine is going to be used for your code. If you know otherwise, please leave a comment. Sometimes you might think you're using CUDA or whatever, and instead you're using maybe a Compute 0 or something else. So it can get a little bit of a challenge, but the big thing we're going to use here is this dedicated GPU memory usage. And what we're going to do is we're going to set up some arrays, like I said, and this GPU has 11 gigs available. We're going to set up arrays that are in total about 8 gigabytes worth of memory requirement. So we'll be able to see when we allocate and set up memory on the GPU, this graph should go way up to about 8 gigabytes. So really, really very useful. You can also, keep in mind, you can also go to, for example, if you want to see what processes are using the GPU, you can go to details, and it shows all of your processes that are running or suspended or whatever. And over here, if you right click on any of these headers, you can select columns and you can select which data is being shown. And if you go down here, you can select GPU, GPU engine, dedicated GPU, shared GPU. You can select whatever columns you want to be shown. You can see here, I've got my GPU engine, which engine is being used, and how much dedicated GPU memory is being used by each process. Now, a lot of people, there's a myth that, if I'm playing a video game, that's the only thing that's using my GPU. That's just not true. If you can see here, I've got a bunch of processes that are using dedicated GPU memory. I've got my Visual Studio is using some, my recording software, Desktop Windows Manager, Explorer, all kinds of processes can use your GPU. So don't think that just because your GPU is being used a certain amount that it's all for your process. It could be something completely different. So here on the left, I have started this application we're going to develop, and I just want to run you through it to show you what functionality we're going to use in this to get some feedback and to see how everything's working with our CUDA. So I started up, and basically it's going to allocate some memory on the heap in our main system RAM, and it took 52 microseconds to do that. And I've also printed out, I've gathered information, as we showed before, on what are the available devices that I can use, and I'm going to be able to select which device I want. So I've got device 0, which is GeForce RTX 2070 Super, and then device 1 is 1080 Ti. Why it's the opposite of this, don't ask me, but now that we've got this information, what we can do is we can select which device we want to run this on. So I'm going to select 1 for the 1080 Ti and see what happens with our memory. So as you can see, what we have done is we have basically gathered some information on this 1080 Ti, how many multiprocessors, how much global memory is available, threads per block, warp size, so on. We've filled 2 arrays of 3.73 gigabytes each and initialized them to 0. So 3.73 times 2 is just under 8 gigabytes. And you can see here our RAM went from about 10. Remember, we were just under 10 gigabytes for the normal processes, and now it's up to almost 18. So here's some good feedback in our main memory. We've allocated RAM on our computer, and we have also, at this point, we have also allocated the RAM on the GPU. So I should be able to go down to my GPU, and you can see right here, we're now up to 8.2 gigabytes of RAM in this chart. So it's working as we hoped. It's allocated on the main RAM, 8 gigabytes, and also on our GPU 1080 Ti, it's up to 8 gigabytes out of 11. And at this point, we have copied memory to the GPU. We filled in the data and copied it to the GPU, but it was already allocated. And then we are going through and we're doing some simple math on the GPU on those elements. And it turns out, in order to get 8 gigabytes, I've got 2 arrays, each with 1 billion elements. So I've got 2 billion integers in those arrays, and that is filling it up to about 8 gigabytes. So it's going through now. At this point, it's copied the data to the device, the GPU, and now we are going through and changing the values in all 2 billion elements in those 2 arrays, and that took 60 microseconds to complete. And here I'm getting the values of 2 specific elements in the 2 arrays just to make sure that it has done what I expected it to. And now we have finished copying the results back to the host. And now what I've done is on the host, now that I've gotten this data back from the GPU, I've done very similar math operations on those arrays, those 2 billion elements. And you can see I'm measuring that it took 1 second to do those 2 billion operations as compared to 60 microseconds on the GPU. So it's giving us a good indication of how much faster the GPU is. And you can see that we're doing 8 gigabytes worth of 2 billion elements. So now that I've got my GPU filled and I've done all my work, I press enter, and you can see it deallocates the RAM on the GPU, and also in main memory, it frees that memory in both. So now you got a really good indication, okay, we've cleared out the RAM and we've done our operations and we're all set to go. Okay, so now that we know some of the tools we're going to use to write our code, the next thing is to understand how CUDA works. And since, honestly, nobody watches my videos, I'm not going to go through all the trouble of trying to repeat some of the work that's already been done by NVIDIA. They've done a really, really nice job. I strongly encourage you to look at the work of Bob Crovella from NVIDIA. He's done a wonderful job. They presented for Oak Ridge National Laboratory here in the US a series on CUDA, and he does an incredible job. He's got a 13-part series, includes videos and homework, done fairly recently, back in 2020. Introduction to CUDA, C++, and really I strongly encourage you, if you want to get involved in CUDA, look at least the first 4 of these to get a really good foundation on how CUDA works and how you do it in C++. To get there, you go to, up here on the left, olcf.ornl, Oak Ridge National Laboratory.gov, and the CUDA-training-series. And you'll get this page and you scroll down and you can select whichever you want. And you click on this, and the first part, introduction, it's got also, if you go way down to the bottom, you've got exercises and presentation. So if you click on presentation, you've got the slides they presented, the PowerPoints, and also recordings. And click on recording, it will bring you to a Vimeo of that particular recording. So, you know, you can download it or whatever you want, but I strongly encourage you to take a look at each one of those. And also there's exercises. You can go to GitHub, to the GitHub repo, and it's got the training series homework. I really encourage you, if you want to understand this, go through and do the homework. Yeah, it's going to take some work, but you know, in the real world, you have to do some work if you want to learn stuff. So I encourage you to look at the videos, do the homework, and you'll be much happier for it. So in the next part of this, we're going to use some of the basic concepts they talk about and develop this simple C++ application that uses CUDA and does everything we talked about before. Basically sets up some huge arrays on your host and your device and does some math operations and does some timing. So in the next video, we're going to step through the code we're going to use to build this. And it will give you some foundations that you can use to make your own CUDA code. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get more than 10 views. I really appreciate it. Take care. Have a really good day. Thanks.